Just be careful. The rational exponents are just like any other exponent we've been doing since the very first day of class. When I have a negative exponent, we wanted to think reciprocal. Reciprocal does not ever mean take a reciprocal of the exponent. Remember, when I saw 3 to the negative 1 power, what I did was I threw to the bottom and put it 1 over 3 to the positive 1. If I have a negative 1/2 power, what I'm going to say is 1 over 9 to the positive 1/2 power. When I take the reciprocal, all I'm doing is making my exponent positive. I'm not taking the reciprocal, and it can be tricky. The more we deal with fractions, the easier it can be to confuse them. Now, when I have a rational exponent, what I would want to do is swing the denominator around as the index. I could say the second root of 9 to the first. Keep the exponent. But the same way I wouldn't want to say 9 to the first power. 9 to the first is 9. I wouldn't want to write the 1 for the same reason. I wouldn't want to write the 2. It's for the same reason of simplification. Now, remember what form these are in. This is rational exponent form. I have a fraction as an exponent. Over here is the radical form. Radical form means I have a radical. Notice I haven't simplified yet. When I take the square root of 9, that's going to be 1 over 3. This is the simplified form. Now, be careful what it asks you. Those directions at the very beginning that no one ever reads, it's going to give you a rational exponent and say write it as a radical form. If you take it all the way to 1/3, it's going to count you wrong, and justifiably so. You weren't writing it as radical form. Radical form is when you have the radical. When you finish a problem and you think it's done and it opens up a second problem underneath, that's when it's going to ask you to now fully simplify. And you're going to need all 3 of those problems within some of your homework problems.